Welcome to The Explainer. Today, we're going to tackle a really common and, let's be honest, super frustrating problem in cloud architecture. We're going to explore how a simple shift in thinking, powered by Amazon EventBridge, can make your applications way faster, much more resilient, and pretty much ready for anything.
So let's kick things off with a question that probably keeps a lot of developers up at night. Have you ever seen this happen? Some tiny, non-critical part of your application fails, like the little service that sends out email receipts. And boom, the entire checkout process just grinds to a halt. Suddenly, customers can't buy anything. It feels like a massive overreaction, right? But it happens all the time.
To make this real, let's meet Timothy. He's a junior developer, and he's totally hit a wall with his new checkout feature. His process is taking 4 long seconds to complete. And all that time, the customer is just stuck staring at that dreaded spinning wheel. And what's worse, if any single part of that process hiccups, the whole order just fails.
So why? Why is it so slow and so fragile? Well, it's because everything is built like a rigid, synchronous chain of commands. The checkout service has to wait for the credit card charge, then it has to wait for the inventory check, then shipping, then email. You get the picture. Everything is directly connected, or what we call tightly coupled. It just takes one weak link and the entire chain shatters.
This is where our senior engineer, Margaret, steps in. She looks at this and gives the problem a name. This isn't just bad luck. It's a specific textbook architectural flaw. Timothy is slammed right into the absolute limits of what a tightly coupled system can do. His checkout service is trying to know too much and do way too much.
So what's the alternative? Well, Margaret proposes a completely different approach called event-driven architecture, or EDA. And the most important word here, the whole magic of it, is decoupled. Instead of services bossing each other around, one service just announces that something happened. It broadcasts an event, and then other services can choose to listen for that announcement and react, all on their own time. And the perfect tool to make this happen in the AWS world is a serverless event bus called Amazon EventBridge. You can think of it like a central message board, or maybe a traffic controller for all these events. It just sits right in the middle of all your services, making sure the right messages get to the right places.
This slide really gets to the heart of it. It is a fundamental shift in thinking. On the left, you've got the old way. It's a micromanager barking direct orders. But on the right, the new way is just about announcing facts. The checkout service's only job now is to shout into the void, "Hey, an order was just placed," and then its work is done. It's a total game changer. And here is the wow moment. This is the payoff. Remember that 4-second wait time Timothy was dealing with? By just announcing the event and moving on, the time the customer has to wait drops to just 200 milliseconds. That is a 95% reduction in latency. The customer sees that beautiful success screen almost instantly, while all the other work happens quietly in the background. Okay, I know what you're thinking. This was the exact question Timothy asked. If the checkout service isn't telling the email and shipping services what to do anymore, how on earth does anything actually get done? It kind of feels like magic, right?
Well, it's not magic, it's just rules. And the process is actually super straightforward. First, the checkout service sends out its order-placed event to EventBridge. Then, EventBridge takes a look at that event and checks its rulebook. If the event matches a specific rule it knows about, EventBridge then fans out, which is just a cool way of saying it sends a copy of that event to all the services that have subscribed to that rule.
So let's look at one of these rules up close. You can set up a rule to listen for any event that comes from the checkout source and has the type order placed. When EventBridge sees exactly that event come through, it knows to send a copy to all of its targets, which in this case are the inventory, shipping, and email services. They all get the use at the exact same time and can get to work in parallel. Now we get to the real beauty of this whole design. What happens if one of those downstream services fails? Let's say the email service goes down for a few minutes. In the old, tightly coupled world, that meant the whole order failed. But what about now? With an event-driven setup, the original checkout succeeds no matter what. The customer gets their success screen because, think about it, the email service being down has absolutely zero impact on the payment service. They don't even know about each other. That failed email event is just sent to a special place called a dead letter queue, or a DL queue. It's a safety net where it can be saved and tried again later once the email service is back online. No data is lost, and the most important part, the customer's order is totally protected. So, the system is faster. It's way more resilient. But you could argue that the biggest benefit of all is how incredibly easy it becomes to add new features in the future. And that's called extensibility.
Let's just imagine a classic scenario. A new request comes flying in from the marketing team. They've got a fantastic new idea. For every single new order, they want to send the customer a welcome text message. In the old system, this would be a huge headache, right? You'd have to crack open that critical checkout code and add more stuff to it.
But as Margaret explains, with EventBridge, the process is almost laughably simple. You touch absolutely nothing in the original code. You don't have to change a single line of that critical checkout service. All you do is build your new SMS service, and you just add it as a new target to that existing order-placed rule. The checkout service has no idea the SMS service even exists, which means there is zero risk of breaking your payment logic. It's amazing.
And for those of you who want to dive a little deeper, there are a few key best practices to keep in your back pocket. The schema registry is a great tool that helps all your teams agree on what the event data should look like. The clean check pattern is a really clever way to handle very large messages. And as we just saw, dead letter queues are your non-negotiable safety net to make sure you never, ever lose data. So the crucial question we're left with is this. It's not just about making your current application work. It's really about building a system that's designed to evolve. By decoupling your services and having them communicate with events, you're not just fixing today's bottlenecks, you're actually preparing your system for all of tomorrow's great ideas. So the real question you got to ask yourself is your system built to break or is it built to grow?